Hello. Today I plan to do 4 things, and the first one is going to be increasing the storage for the VM. Well, actually, I'm not increasing the storage, but I am making sure that the file system is extended to the full 180 gigs that I have given it during the creation of the VM itself. The second thing is I will take a snapshot because last snapshot got deleted with the old VM that we cloned into new one and then deleted in the last episode. The third thing is I'm going to install Docker, and the fourth is Portainer on top of Docker. So let's go ahead and start. Now, this is the Proxmox Web GUI, right? We pretty much don't need to use it anymore. Most often we will rely on SSH or the services themselves directly, and rarely we will come back to Proxmox if we need to. I mean, definitely we'll come back to it when I create the snapshot, but for now, we can do everything we need from the SSH terminal. Let's do df-h. So if you do df-h, you will see that I only have 76 gigs, well, some extra stuff in here, but nowhere near the 180 gigs that I have given it. That is because Ubuntu server did not use the full 180 gig when I created the VM. So what happened is our volume group is actually still like 180, and I can test that with sudo vg volume group display command, and you will see that allocated is 89 gigs and free space is still 89 gigs. So in total, we do have something around 178. What happened is Ubuntu Server 24 created the local volume with 88 gigs, half of what I had. And it probably, I probably didn't pay attention during the installation to increase it, but it's still fine. We can increase it. So what we can do is we can allocate the free space to the local volume, and then we can extend the file system to use all of it, right? So I'm gonna copy and paste the command here directly instead of typing it in. So it's essentially local volume extend -l 100% free, like all of the free stuff, and give it to Ubuntu VG Ubuntu LV local volume. Okay. Now, if we do VG display, does it change? Yeah, we no longer see the free space, but if I do df-h one more time, we still see 88 gigs, 76 gigs, because we have given it to the local volume, but we have not extended the existing file system. So to that end, I will use resize to files to fs. So it will essentially use all of it. So now if I do df-h, we can see all of the available space has been assigned. Perfect. I will just in case reboot. Well, actually, I don't need to reboot anything because the next thing we wanted to do is take a snapshot. And for snapshot, we can, let's do it from the console. Well, and let's do sudo power off. We need to shut down the VM to take the snapshot. Maybe I can take the snapshot while it's live. I don't know, maybe. But it is generally better to shut it down and then take the snapshot if you have the luxury of it. I'm gonna name it fresh install and call it Ubuntu 2404 fresh install. Take a snapshot. Perfect, and it's done. So now I can start the machine up back again and proceed with the installation of Docker. All right, machine is back and up and running, and I can access it via SSH. For Docker and Portainer installation, I'm gonna rely on their own official guides. This is for Docker installation, right? Yeah, install Docker engine on Ubuntu. Now, the first thing they want us to do is if we have anything like lingering around older versions or whatever, this command is gonna go ahead and remove it. I might have typed my password wrong. Yep. Perfect, nothing to remove. And then, so yeah, this portion is set up Docker's apt repository. Okay, this is to set up the repository. I'm gonna copy some of them line by line and some of them in bunches. If we do sudo apt update, perfect. There are some packages that can be upgraded. We can do it in the end. Oh, well, actually, let's do it. Sudo apt upgrade, and then sudo apt auto remove, just in case. Excellent, upgrades completed. It's telling us we should user session running outdated binaries. Okay, we will restart it anyway, so it's fine. The next step is installing some, let's say, dependencies, packages. All right, these are also installed. And then I'm gonna copy all these 3 lines. These are GPG keys used to make sure that the packages are coming from the correct repository. So it's essentially ensuring authenticity and integrity of the packages, Docker packages that we will be pulling from these repos. Here I can create this file and then copy and paste the contents of it, but this is already a ready EOF command, and I can just copy and paste all of it. Added it there. Let's just in case, where's this command? Cut the contents just to make sure. All right, we can see the output. And now to install Docker. So it comes with Docker Community Edition, Docker CLI, Container IO, Buildex plugin, Docker Compose plugin. Okay, so it has the Docker Compose plugin. Great. It says unable. Oh, did I update? No, I did not. From the sudo apt update, and then back to installing Docker. Perfect. Docker should be installed. Let's just check with systemctl. Status Docker service. Yep, it's up and running. Do they want us to test hello world? Yep, let's do that. Perfect, this means it's all good. And if I do ps-a, well, not ps-a docker, ps-a. Oh, okay. I should probably add myself to a Docker group as well, so I can use Docker commands without sudo. The clanker is telling me I can do sudo user mode. Yep. Add myself, and so the $user is gonna be your user. This is like environment variable, so we can copy and paste sudo user mode -ag into the Docker group my user. All right. Now, if I do, let's see if I can do it without exiting. Docker ps-a. Okay. All right, perfect. I essentially exited and then entered SSH again just to restart my session. So I can delete this container. Docker, I think the command is docker rm and then the container ID. Just copy and paste it. Docker ps-a. So docker ps command is going to show you running containers, and ps-a created all the containers that you have. And then we have docker images, ls, I think. No. Docker images. Yeah, okay, so it's gonna list all the available images. I don't need this. Can I delete it with this? Let's say docker image rm, and then, yeah, I think it did. Docker images, nothing. All right, fresh Docker. Let's go ahead and directly install Portainer as well. It's going smoothly so far. All right. The first thing they want us to do to install Portainer is to create a Docker named volume named Portainer_data. Now, here's where I'm gonna divulge a little bit from the official installation guide, and this is my reasoning. So if I go into /opt, I want to create a directory in here named, let's say, mk directory -p to create the parent directory as well, Docker, and name it Docker, and then /app data. I cannot because I need sudo. All right, and I want to well, make it my own, give my own user permissions. Let's do chown -recursive $user Docker app data. Of course, sudo again. Oh, not container, Docker. And as I can see, it has my users permissions. Does Docker also have my users permission? No, perfect. Docker app data. So what I want to do is prefer using bind mounts instead of named volumes. And my reasoning behind it is gonna be, this is a homelab that the files of the services, I want to be able to access them from the host machine, and I want them laid out in one place, like in one directory tree, let's say, so I can always come and check these files individually if I need to, and back them up as well. So my current idea is laying all of those servers. Let's actually create, like, so let's make directory and call this Portainer, right? And then, for example, if I have paperless, I'm gonna do mk directory paperless, yada yada yada, and then for other services similarly, right? And then have everything in this app data as a host file. Now there's debate, like I spent an hour like thinking about it. Should I go with named volumes or bind mounts? There are pros and cons for everything, for both of them, but I think I'm gonna stick with this layout. All right. So great, I have the directory created. So I will be using this directory instead of the named volume. Now to that end, I will need to make a little bit of changes, small change to the docker run command, but let's take a look at it, right? So docker run port 8000, 94943, that's good. I want to name it Portainer, perfect. Restart always. So when the machine reboots or like something happens, it always restarts. It does need access to Docker sock because Portainer will be creating different Docker containers, taking them down, and etc. And here, instead of that named volume, Portainer data, I'm going to be using my bind mount. And then the Portainer itself as well. /Portainer, and mounting it to the data directory inside of the container. And this is essentially, yeah, community edition LTS Portainer. Hit enter. Perfect. So now I should be able to access it via 8000 or 9443. Let's go to, sorry. Let's go with 8000. Oh, no, it's not 100, it's 101. All right, and now let's try 9443. It's complaining about HTTP, HTTPS. Well, perfect. It went into HTTPS, great. Yeah, we know, because we don't have these public-private CAs and etc. like in my browser, so it's complaining about certificates. That's great. Now it wants me to create the admin user, and let me grab my password from the password manager. Okay, I generated a random password with my password manager. Allow collection of anonymous. Nope, we don't need that. And then create user. And that's it. Portainer quick setup page. Okay, we're not going to be connecting to any environment because this is the environment we're going to be using, and I'll just click proceed, and then this is the live node. Perfect. So what we did is we extended the local volume file system to use all of the available space. I created a snapshot, and then we installed Docker, and then on top of it, we installed Portainer. Everything went suspiciously smooth, no issues. And yeah, I guess that's it for this video. So this is my home lab journey so far, and I hope to see you in the next one.